So we had discussed about refractive index, but we haven't studied the definition of refractive index. So here in this slide you can see the definition of refractive index. Refractive index, also called as index of refraction, it describes how fast light travels through the material. Also, refractive index helps us to understand how much the light ray will deviate when it passes from one medium to second medium. And refractive index is a dimensionless quantity. Refractive index is a dimensionless quantity, and you will understand more about this definition when we discuss about the rarer and denser medium concepts. Okay, so what is refractive index? Refractive index, also called as the index of refraction, it describes how fast the light travels through the material, or it also helps us to understand the extent of deviation of light ray when it passes from one medium to another medium. And also there is no unit for refractive index. It is a dimensionless quantity. It is just a number. So do you think there is any relationship between refractive index and velocity of light? We had studied about refractive index. So do you think there is any relation between refractive index and velocity of light? Yes, of course. What is the definition? The definition of refractive index itself, how fast. It helps us to understand how fast a light will travel through a medium. Also, there is another definition for refractive index. So you must concentrate on this definition more. The refractive index is the ratio between speed of light in a vacuum and the speed of light in the medium. Okay, you know one thing. See, the speed of light in vacuum or air is denoted by C. It is not denoted by V. It is denoted by C. So what is C? C is speed of light in vacuum or air. Okay. And what is refractive index? It is the ratio of speed of light in vacuum by speed of light in a medium. So C by V ratio is refractive index. And how do we arrive at this equation? That is most important. So I had told you there is a relationship between refractive index and velocity of light. So we had studied two types of refractive index, N21 and N12, isn't it? And N21 can be denoted by N2 by N1. N12 can be denoted by N1 by N2. And when do we obtain N21? See, consider this figure. This is the boundary separating two media. This is first medium. This is second medium. And let N1 be the refractive index of first medium, N2 be the refractive index of the second medium. This is the normal, and light ray has entered or incident on the first medium. At the boundary it will bend and it will pass. This is angle of incidence and this is angle of refraction. Okay, so here bending occurs in the second medium, so we obtain refractive index of second medium with respect to first medium. And here V1 is the velocity of light in the first medium and V2 is the velocity of light in the second medium. Okay, so there is a relationship between velocity and refractive index, and we can write N21 is N2 by N1. And N2 by N1 is equal to V1 by V2. Similarly, we can write N12 is N1 by N2, isn't it? N12 is N1 by N2. So N1 by N2 is equal to V2 by V1. So this is the relationship between refractive index and velocity of light in the respective media. So N2 by N1 is equal to V1 by V2. Okay, you must study this relation. This is the relation between refractive index and the velocity of light in different media. Suppose here the first medium is air. So if first medium is air, I told you the velocity of light in air or vacuum is denoted by C. So V1 is now replaced by C. If there is no V1, no sense of writing V2. Listen carefully. If there is no V1, no sense of writing V2. So we can represent the speed of light in second medium just by V. Okay. Now our equation becomes N21 is equal to V1 by V2 will change to C by V, because V1 is replaced by C and V2 is replaced by V. So our equation becomes N21 is equal to C by V. Okay, and again, see, if the medium is air, refractive index of air is 1, approximately 1. Refractive index of the medium is 1. So refractive index N2 by N1 is equal to C by V. We have got that relation. N21 is N2 by N1, isn't it? N2 by N1, that is equal to C by V. So if the first medium is air, the refractive index of first medium is 1. So N1 will be replaced by 1. If there is no N1, no sense of writing N2 here. So on the LHS side we get N. So the ratio N2 by N1 has become N. And we got the relation N is equal to C by V. See, so this is the relation. And this N is known as absolute refractive index. So what is N? N is known as absolute refractive index. Okay, and this absolute refractive index is the ratio between speed of light in vacuum to the speed of light in the medium. So obviously there is a relationship between refractive index and velocity of light. Okay. Now, what are the applications of refraction? See, mirage and looming are optical illusions which are a result of refraction of light. A swimming pool always looks shallower than it really is because the light coming from the bottom of the pool bends at the surface due to refraction of light. Then formation of rainbow is an example of refraction, and you will understand about the rainbow formation and the role of refraction in our next chapter. When white light passes through a prism, it splits into its component colors. That is also due to refraction. You will study about it in the next chapter. Okay, so all these are applications of refraction. Next, I told you, you need to identify a denser and rarer medium. So you can do that with the help of a refractive index. See, on the slide you can see some refractive index values of some medium, isn't it? There is a table, and this table is there in your NCERT textbook. So just go through that table, and here we have different media, and the refractive index of different media is listed here. See, air 1.0003, approximately it can be considered as 1. Ice 1.31, water 1.33, alcohol 1.36, kerosene 1/44. Like that, turpentine, fused quartz, crown glass, ruby, sapphire, diamond. Here, see, we can identify denser and rarer medium with the help of refractive index. How? Material having high value of refractive index will be a denser medium. Material having a low value of refractive index will be a rarer medium. Okay. Material having high value of refractive index is a denser medium, and material having a low value of refractive index is a rarer medium. So air having the least value of refractive index, so it is the rarer medium. But look at diamond. Diamond has the highest value of refractive index, 2.42. So it is the denser medium among all other media. Okay, so from the values of refractive index we can identify denser and rarer medium. So if air, ice and water is given, which is the denser medium? Yeah, water, because water has the highest refractive index, 1.33 among all the other three medium. Okay, so thus refractive index helps us to identify the density. Which density? Optical density actually. It is not the mass density, it is optical density. So refractive index helps us to identify the optical density of a medium. Material having higher value of refractive index is a denser one. Material having low value of refractive index is the rarer one. And whenever light passes or when light travels through a denser medium, its velocity will be less. And whenever light travels through a rarer medium, its velocity will be more. Okay, so light travels faster in a rarer medium and light travels slowly in a denser medium. So thus refractive index helps us to identify the velocity, or it will explain how fast light will travel through a medium. Now can you connect between refractive index and velocity? Yeah, by looking at the values of refractive index, we can tell how fast the light ray is traveling through the medium. If it is having higher value of refractive index, then light will travel slowly through that medium because it is the denser one. But if the material or if the medium has less value of refractive index, light will travel faster through that medium because it is a rarer one. Okay, so that's about refraction and refractive index. These two concepts are very, very important. So please go through that. If you have any doubt, please contact me. So with this, I am concluding today's session. We will meet in the next session with a new concept. All of you stay home, stay safe, and notes of the topic, YouTube video have been uploaded. Just go through that. You will get a much clear idea of this concept. Okay. So we will meet in the next session. Till then, take care all of you.